Hello, welcome back to Math 152. We're going to cover today section 2.3. This is more graphs for quantitative data. We're just going to be doing a little more than what we did last time. Our objectives for today is construct stem and leaf plots. We're going to construct some dot plots and then some time series plots. So what are stem and leaf plots first, and how do we construct them? Stem and leaf plots are a simple way to display small data sets. In a stem and leaf plot, the rightmost digit is the leaf, and the remaining digits form the stem. Consider the 14.8 and 2,739. The 14.8, the 14 is going to be our stem. The 8 is going to be the leaf. Now, right now, it doesn't mean anything to us, but once we put it all together, it will. 2739, I'm going to take the tens digit, put that over into our leaf spot. The 273 is now going to be our stem. So how does that look? So the following table presents the U.S. Census Bureau projection for the percentage of the population aged 65 and over for each state and the District of Columbia. Construct a stem and leaf plot for this data. So this is what it's going to look like. We're going to make a vertical list of all the stems in increasing order and draw a vertical line to the right of this list. For each value in the data set, write the leaf next to its stem. For each stem, arrange its leaves in increasing order. So basically, I'm going to go through all the data. The stem, I'm going to write out here to the left. So here's an 8, and we saw 81. So we're just going to shorten that 81 to an 8/1. We saw a 90, so we see a 9/0. Now here looks confusing. What we're actually seeing is we're seeing 3 digits in that 10 to 11 range, just like we did kind of classes a while ago. This is kind of, you can kind of think of this as a class. Here's the stem. We saw a 107, 102, and 105. So this shortens this down. Instead of having all those 3, here we've got 3 digits in that 100 range. So for these, we saw 115 and then another 115. So it's not 1155, it's 115, 115. 12, we've seen a lot of them in that 120 range. We saw 120, 124, 127, all the way continuing on. And now on this, they're not really listed in order, right, on this side. But eventually, we're going to move it over, put them into order, and this kind of helps us out a little bit. 81, 90, 102, 105, 107, all of these things are listed in order. Now the nice thing about this is as we go on, we can take a look at this in the stem and leaf plot and basically tell where most of the numbers are. Where we've got this bar, as you will, we see a lot of the numbers in the 120 range, the 130 range. Most of them are in the 130 range. And then the 140. But if you consider this little group between 120 to 140, we see most of the data. And these are pretty close to the same numbers, 8, 9, 10, so 80, 90, 100, all the way through. So this looks pretty symmetric as well, using some of our terminology from last time. We can also do back-to-back stem plots, and that allows us to look for one stem. We can compare things across different sets of data. So here was, consider the following course averages from an English class and a history class. Here's the English, the history. The classes can be compared with a back-to-back stem and leaf plot. So if this teacher had 2 classes, she taught an English class and a history class, and they wanted to compare the averages, we would go through, construct everything. So for our English, there's our 45, our 57, 62, 66, 68, 69. And then down here in our history class, we're still the same stem. There's nothing in the 40s. At the 50, I've got a 59. That's my lowest. The 71, I'm sorry, the 59, the 61, 67, and then the 71, 71, 73, 271s. So here, by putting it into this form, we can compare the data from each class directly. We can see that the history class has higher averages. They had more scores in the 80s, more scores in the 90s, and there was actually a 100, see it down here, but there were no 100s in the English class. So that helps us to compare data from data sets. Here's another way that we can do. We can represent data in terms of dot plots. Now let me go back and let me make one more statement about this before we go on. The nice thing about stem and leaf plots is that I can recover the data from a stem and leaf chart. Okay, I've got my plot. I can basically start back and work backwards to develop this. I don't need these tables anymore. I've got a good way to represent them visually. Small data sets, I can only do this with small data sets, but I can go back and I can give you all the data back again. There was a 45, a 57, 62, 66, 68. So I can do the English class, and I can rebuild this data from the history class. I didn't have any things in the 40s. I had a 59, a 61, 67, and the 100. The dot plots, I'm going to do something kind of similar, but I want to do all my stems along a number line just down at the bottom. I'm going to go through, and basically every time I see this number, I'm just going to put a dot for it. So if I see a 0, I'm going to put a dot. I'm going to go through, I see another 0 there. There's a couple of zeros here. So I'm going to, every time I go through and I see a 0, I'm going to put a dot, 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 add up another one. So there should be 1, 2, 3, 4, 5, 6 zeros. Here's my ones. I see 2 1s. There should be 2 1s in here. There's a 1, and there's a 1. There's my 2s, my 3s, all the way through. Now again, this is a nice visual representation. I can tell you where all the data is. Most of them 2, 3, 4. There's a few of the 0. Up to 6, most of the data lies in here, and then I've got some of these things out here. We'll call these things outliers later on. If I were considering this as everything is distributed out here, I would consider this right-tailed, positively skewed. So the dot plot gives a good indication of where the values are concentrated and where the gaps are. For example, it is immediately apparent that the most frequent number of children is 2. There's the most frequent, that happened most. And only 4 presidents had more than 6. This was the number of children had by each of the presidents of the U.S. and their wives. I always thought this was interesting. This one president had 15 children. So before we get started onto that, let's go over into Excel. And I wanted to do a way that you could represent, to build a nice quick dot plot. And if I had all these data, let's say if I had a data set that had 2, 3, 4, 5, 5, 6, 6, 6, 6, 7, 8, 9. Dot plots and stem and leaf plots are only good for if the data is really tightly packed together and there's only a few things. You don't want a whole lot of those. It gets kind of cumbersome. But here I had a manageable set. I took this and I represented this to get it into Excel in a nice, easy way. I just said here I had 2, I had 1, a 3, 1, 4, 1, 5, 1. And here what I did is I said I had a second one. And 6s I had 1, 2, 3, 4. And what I'm going to do is I'm going to plot these as pairs of data, and that way it gets a dot, 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 the 7, 8, minus 1. So when I go here, I can select my data. I'll open this up for you. Insert, recommended charts, and now I'll go to all charts. Let's do the XY scatter. And I should have cancel. There, that's what I'm looking for. So now I've got the 2 dots showing up. And I can change up here. These are just some different possibilities. This one looked nice here with these little circles. They're kind of bubbled out. I can change what's down on the bottom. Excel lets me play. Let me see if I get this. There's my format axis. Instead of having major units as 2, I can have 1. So now I've got all my 0, 1, 2, 3, 4 all across the bottom. And if I want to, I can go here, my axis, select, and get rid of that vertical axis over here so that everything looks just like a number line. I don't want a trend line in there. Maybe that's a little helpful. So let's go back. Slide. So another type of plot that we are interested in is a time series plot. Time series plot may be used when the data consists of values of a variable measured at different points in time, hence a time series. In a time series plot, the horizontal axis represents your time, the vertical axis represents the value of the variable excuse me, that we are measuring. So here's some data. Following table and time series plot display the closing value of the Dow Jones Industrial Average at the end of each year from 2000 to 2012. So along the bottom, here's the year, and here was the closing Dow average. And then basically, they just run a line between these points. Here's the data that we have. Those are the dots. And then they just add an extra line to help visually follow the flow. So these type plots are very easy to do in Excel. I'm going to go back over to Excel, go to this sheet. Basically, I selected the data and then copied it directly into Excel. Sometimes you can do it directly from the slide. Sometimes you have to go to the textbook, grab it from the textbook. So what I want to do is I want to highlight everything to generate my time series. Go back to Insert, these recommended charts. And I want to do a variation, so I want the dot to look just like that. Okay, and then I can do different things. Add data labels. I can put points up here. I can do center above, below, different places. Data call out. I can do them like this and then position that call out for each one. Like that. So I hope that's helpful as well. That's a time series. So you can also do this in TI-84. This time we'll go back to the list. So we would do our X values. Here's our time. The Y values in our L2. Then your second Y equal. And then you're just going to select, yeah, turn this thing on, do this type of data, whichever one you want to select. And then here's your X list, your Y list, a color if you want to do it. And then zoom 9 to view the plot. So from this section, here's some things that you should be able to know and would be tested on. Stem and leaf plots, how to read them, how to construct them. Dot plots will be used frequently throughout the course as a good way to see some things. And then time series plots. So know those things. That kind of finishes up this section. I hope you found it constructive. See you next time.